Hi, my name is Sherekas and I'll be doing my presentation over X-ray telescopes. I'll be telling you about the structure of telescopes, what it is used for, and how they are used. First, I'm going to give you a definition of X-rays. X-rays are light with wavelengths. This in turn falls in the portion of the electromagnetic spectrum between ultraviolet light and gamma rays. Next, I'll talk about what are X-ray telescopes used for in astronomy. Originally, X-ray telescopes are used to observe the sun in astronomy. The only X-ray source during the time that X-ray originally came out produced a great amount of measurable signal. The first X-ray picture of the sun was taken by a rocket-borne telescope in 1963. The first orbiting X-ray telescope flew on Skylab early in the 1970s and recorded over 35,000 disk images of the sun. The uses of X-ray telescope. X-ray telescopes are used to serve as mirrors. When using an X-ray telescope, one must use material which reflects the X-ray photon, so that X-rays are not absorbed, and design one telescope to where the X-ray photons hit the mirror at a small grazing incidence, basically so that they would be reflected. The difference between an X-ray telescope and your everyday telescope. X-ray telescopes do not reflect off mirrors in the same way as visible light does. Due to their high energy, X-ray photons penetrate into the mirror much the same way that bullets do into a wall. How does one detect an X-ray telescope? A telescope is a device that collects radiation from astronomical sources such as stars, galaxies, and etc. and delivers those photons to the detector. The detector in turn then determines the best direction possible, brightness changes, and spectral intensity of color of the incoming photons and when they arrive. X-ray detectors, in contrast, usually detect individual X-ray photons, which react with the detector. So instead of measuring a spectrum of light or a bright blob of light, they measure each individual photon and then over time accumulate enough measurements to make an accurate picture of the total source. Since X-ray photons have a higher energy than optical photons, an individual X-ray photon is easier to notice. So counting individual photons is not that difficult. In most sources, by the time their light arrives at Earth, they tend to have low overall count rates, number of photons hitting the detector in general. So that's my information on X-ray telescopes.